next presenter, flexible electronics, Karl talking about OLED.
Okay. Thank you for the introduction. So I'm going to begin my pitch tonight about an example of working with the CSIRO. So this was Andy, and he was an industrial design student from Monash University, and he had been reading about OLED technology and thought that he would like to use it to create a lamp for his final year project. Now, most of you, or some of you, may already be aware of OLED technology. You know, many of you may even have a mobile phone with an OLED display, and perhaps even a few early adopters even have an OLED TV at home. But for those who aren't familiar, an OLED, or organic LED, consists of several semiconducting organic layers sandwiched between two electrodes. So much like the printed solar cells that Fiona just spoke about. However, contrary to the solar cells, when you apply a voltage across the electrodes, these devices emit light. So, now, Andy, during his course of his internet browsing, came across the fact that we have been developing new materials for OLEDs at the CSIRO. So he came along to our flexible electronics labs in Clayton to discuss his idea. And we were able to recommend a commercial supplier of OLED panels for Andy's design. And we worked with him to refine that, basically in just the terms of the mechanical and the electrical operation. Now, an OLED also differs from a, standard LED or point source of light in that it's a surface area point of light. So this means that it does not require any external diffusers or optics to spread that light, and it has high efficiency, which means that the light is cold to touch. It can be made extremely thin, flexible, and even transparent. So we worked with Andy at our site, and we used our on-site engineering facilities to fabricate and assemble the components of the lamp, including all of the electronics, the hardware control, and even programmed a wireless interface. And following that, Andy's lamp was presented as part of a student work at Monash University, where it was selected by the Melbourne Movement to be exhibited at the Salone Satellite, which is the world's largest furniture and lighting design fair in Milan, Italy, earlier this year. And it was there that it was featured as an awards finalist. So that generated widespread news within the design community on their websites and blogs. And it also led to a notable mention on the Core 77 Design Awards. And thank you. And so where is Andy now? Well, he has taken up a position with Apple in the United States, where he's now designing the next generation of iPads, iPhones, and even the iWatch with its plastic OLED display. And so I hope my story tonight has given you an example of how, working with the CSIRO, we can introduce new technology and implement that to help you achieve your goals and hopefully succeed.
That's great, thank you. So just to kick off more inspiration and more Andys, can you just quickly walk us through the top 5 or the top 10 kind of contexts in which we're likely to run across OLEDs like today or this year? Or
so
I'm familiar with TVs. What else?
TVs, mobile phones. Their first implementation was in a lot of very small electronic devices, MP3 players and all the rest. OLEDs, due to their efficiency and the fact that they don't require a backlight, means that they're going to increase, the lifetime of a battery in mobile devices. So that's where the very, very highly anticipated use is. But as I mentioned, OLEDs have been driven by the display industry. They see that as its main money driver, but a lot of the same companies like LG have now been developing OLED panels for interior lighting, and those are now becoming available. There's examples of OLED-only boutique luminaire, shops in Fifth Avenue in New York and London. So
like, was it like a post that I could unroll and like blue tack to my wall, and that's a light?
It's getting to that point. So there are some commercial suppliers now you're able to purchase flexible, so OLEDs on a plastic substrate, size of 300mm by 300mm squared. So
okay, so here's a question out of like science fiction, and some of the questions are going to be science and some of them will be science fiction. But I have dreamed for years of like going to the hardware store and getting a spray paint and spraying it on a wall, and that's actually then like a monitor, and like maybe it needs maybe it's sort of put something on that does Wi-Fi or some sort of other interface. But if it's organic, then how organic is it? Like how far away is like a spray on light emitting surface?
Well, it's probably going to be very difficult to get a spray on, given that it's an OLED, as I mentioned, is a sandwich structure, so you're always going to need to actually perhaps spray on two materials. So you'd have to do one coat or three coats of different materials.
I do that in my painting anyway, so that's not a problem.
Fine. I mean, it's not that hard. Like as Fiona made a mention where we have done some flexible devices, and that literally is 3 layers. Today's technology, you've typically with those electrodes, one is indium tin oxide, which is a transparent conductor. That's a brittle material that's normally sputtered, and we also deposit a metal electrode, but there's definitely silver inks and the likes these days, and there's also conductive inks like P.PSs and things like that, which can also act as the transparent electrode.
Cool. Yep. Sorry,
Karl.
Yep.
I just was curious, that example of collaborating with you guys, is that sort of informal, or is there some actual door that I can go and knock on?
Well, in that case there with Andy, it was very informal. As I said, he just found us and contacted us directly, and it was a fortuitous time because we were actually looking to actually do something ourselves. So that worked well for both of us. But I believe tonight we're going to have our last presenter. We'll also be talking about how SMEs can engage with CSIRO. But I mean, the first approach can be simply, finding a contact on the website and emailing them or calling them directly. Get on the phone, it's always easier.
Just to follow up on that, like I've had experience where I approach academics or other researchers, and they're like, "Well, you're a member of the citizenry, and I don't want to talk to you." And I'm like, that's.
Yeah.
So did Andy have like some magic formula, or had he bona fides? Did he have bona fides, or
I think Andy did have a little, foot in the door. By the way, he had a friend who was doing work experience in our group at the time, so he noted that. But that said, since then, I'm already working with another designer from Swinburne University this year to help him realise a similar lighting.
So jump on LinkedIn,
design.
work out who you know at CSIRO, and that's it.
Yeah, but yeah, get on the phone. That's easy,
Was there another question over here? Yep. Sorry, you can be next. So in front, and then you next.
In terms of OLEDs, there's a hell of a lot of money and a hell of a lot of attention going into trying to turn those into big screen TVs, something like LG and so on. And with the best will in the world, you've got a lot of money. What do you see yourself as being? Are you researching particular areas, or are you just a centre of excellence, or what's your game?
So, our primary focus has been on the development of phosphorescent OLED materials, and in particular a blue emitting compound. So today's OLEDs have phosphorescent reds and greens, and the phosphorescence just means that it's much more efficient than traditional fluorescent materials. So essentially you can collect every charge and generate a photon from that. Blue, given its higher energy, is typically much harder, so you can think of the evolution of lasers, say red, green, blue. So blue, phosphorescent OLEDs
Blue's
are
where
still
it's
being
at.
developed. Yeah.
Blue's big. Why is blue interesting?
Well, you need blue to generate white light. So white light is generally made from a two colours, so a blue and a yellow mixed together to generate a white light. So blue is very important.
All right.
Yep.
Oh, just one more over here and then we'll move over.
Exactly how organic can this really become OLED? Like a small OLED light grow into a big OLED light after a month?
Can they mate and breed?
I guess I'd have to, that would be really pushing the envelope, I guess, with self-assembled monolayers or something like that. I'm a physicist by background, so I'd have to defer to my chemist, but at this point in time, I don't see that happening. It's going to be where you apply it, it's where it's going to be, so.
Time for one more question from the audience. Yep.
Do you see a time when you'll be making them into OLED thread?
OLED threads?
You say it's a sandwich. So it's
Yeah.
natural.
Yeah.
It's small enough.
Yeah, there are definitely examples in the
Like a
academic
falafel
literature.
or a shish. Like a falafel or a shish instead of a sandwich, like a long thing that's... All right, that didn't work.
Yeah, look, there are examples where people have been depositing the materials onto fibres, so that way they can, thread them into fabrics, and so you'd have a lot of them in. But I mean, there's probably other competing technologies there with optical fibres and that might be a little bit more beneficial.
Why would I? Have you got a particular use case for a cylindrical OLED?
Just for commercialization. I'm thinking clothing that advertises, clothing that can change colour.
Right. I was thinking jewellery, but like personal wear.
Yeah, like an updated version of the 70s mood ring.
Yeah. Like a shirt.
Why not, Check the designs.
Oh, one more question.
Would we be able to 3D print this thing?
That is a real possibility moving forward. We do have some activities where we're looking at actually modifying some 3D printers to actually enable customised designs. So any two-dimensional shape that you can think of, that's definitely possible. I mean, when we talk about 3D printing of this, they are very, very thin layers that are going in. So it's additive manufacturing, but it's not 3D in terms of specific height. But it is a real possibility moving forward.
So 3D printing of OLEDs, not yet, but one day. Thanks very much, Karl. That was great.